Question number 6, in the diagram ABCD is a square. So the moment we know that this is a square, we will have all the 90-degree angles. And what is the other property of a square? All the opposite sides are equal, all the four sides are equal to each other. Okay, and we know that APQR is a rectangle, so we will also have 90 degrees on all the different sides. And we know that the opposite sides are equals to each other. So the opposite sides are equals to each other. Question part A. Show that angle DAR is equals to the angle BAP. So this is the angle DAR. We shall let this angle be X. If that is the case, what is the angle BAR? This one will be 90 minus X. And looking at angle RAP, what will we have? Angle RAP is also 90 degrees, and hence we will be able to find that angle BAP is also the value of X. So how do we write this down? So we are going to let angle DAR be X, and if that is the case, angle BAR will become 90 minus X. What is the reason? Because ABCD is a square. Okay, and then we will be able to get angle BAP, which is found by taking the angle RAP, which is 90 degrees, to subtract away the angle RAB, which is 90 degrees, minus X. Remember to put the brackets so that the sign will be correct, and you will get back X, which is equals to the angle DAR. Sure. Now we already know that angle DAR is X, is the same as angle BAP, which is also X, and we have all the different sides. Okay, show that triangle ARD is congruent to triangle APB. So let's take a look at the different values and angles or length that we have now. Now just now we already established that in ABCD is a square, so we will have right angled triangles. So angle ADR is actually 90 degrees. This one will be able to match with angle ABP, which is also 90 degrees. Now that we will have one angle, so let's take a look at the properties that we have: SSS, SAS, ASA, and the last one RHS. Let's take a look. Since we have a right angle triangle, can we use RHS? We know that the opposite sides AR is the same as PQ, but AR is supposed to correspond to AP, so we cannot use the hypotenuse. So in this case, RHS is out. And since we have already one angle, so SSS is also out, and we do not know the hypotenuse anyway. So what other sides or angles can we find? We already have one given angle shown in part A, another angle, so we need to find one more side. Where is this other side that we can find? We know that previously ABCD is a square, so AD will be equals to AB, and this is a square. So now let us write down the proof. In triangle ARD and APB, we will have the first one, the ASA property, the first angle DAR to be equals to the angle BAP. This reason is shown in A. Second one will be the side AD to be equals to the side AB, because this is sides of a square. And the last one will be the angle ADR to be equals to the angle ABP, which is equals to 90 degree, because this is a square. Right? And last but not least, we shall write our statement. Therefore, triangle ARD is congruent to triangle APB by the ASA property. Last but not least, explain why APQR is a square. Now, does this question look familiar? We have already done this before. There are two conditions for it to be a square. Firstly, all the angles must be 90 degrees. So we will have angle RAP to be equals to the rest of the angles, which are angle APQ and PQR and QRA to be all 90 degrees. And lastly, we need all the different sides, all the sides to be equals to each other. And how can we do that? We already know that AR is equals to the side AP, because this was proven to be the congruent triangles, the sides of the congruent triangle in the previous part. So shown, not shown, so it will be triangle ADR congruent to triangle ABP. And then it will be equals to the rest of the side as well. AP is also at the same time equals to RQ and also equals to PQ. Since all the four angles are 90 degrees and all the four sides are equal, therefore APQR is a square. That's it.